The primary purpose of today's activity is to find the velocity of a toy car on a flat horizontal surface. Normally, that flat horizontal surface will be the floor. The apparatus that you're going to use is diagrammed on the board here right now. Now, there's a lot of this that you're not going to recognize. In fact, probably the only things that you're going to recognize would be an iPhone and a toy car. This toy car is motorized. It's going to move when you turn on the switch at a constant velocity on the floor. What we want to do is measure its motion, record its motion. And we're going to do that by using what we call a motion sensor. That motion sensor sends out a little sound signal 10 times per second. That sound signal bounces off of the toy car, comes back, it's timed, and it measures the position of the car based on how long it takes that sound signal to return. Again, 10 times per second. But the motion sensor in itself is useless. That motion sensor has to record data somewhere and then transmit that recorded data somewhere. So, in order to record it, you're going to hook it up to this thing that we call an air link. The air link will record and save that data. But in order to get it somewhere so that we can use it, we have to actually connect the air link via Bluetooth to your iPhone, which is going to have an app, a free app downloaded, which is going to allow you to interface with this air link and collect the data of the position and time of this car 10 times per second. Does that, in concept, make sense? Now, you don't know how to connect it right now and how to deal with, how to send the data. Okay, that's comes a little bit later, right? In concept, what we're going to do is turn on this car, allow it to move down the floor at a constant velocity, aim this motion sensor at it, and record the position and time of this car 10 times per second. All right, a couple little things. First of all, this motion sensor, it pivots. You want this motion sensor not to be pointing at the ceiling because you don't want to measure the position of the ceiling. You want the motion sensor to be pointing at the car. Last class, we were looking at this. A couple of groups were having a little bit of trouble collecting data. I looked at it. The motion sensor was aimed at the floor, or the motion sensor was aimed at the wall. Okay, if the motion sensor isn't aimed at the car, you're not going to measure the position and the time of the car. So make sure it's aimed properly. If you're having trouble with that, just call me over and I'll help you out. The second thing is, if we take a look at a magnified version right here of the motion sensor, there's a little setting on the motion sensor, a little switch. You can go back and forth between a little stick man and a little cart. You want to have it on the little cart. When you have it on the setting of the little cart, it enables this device, this motion sensor, to measure the position of an object that is A, small, and B, nearby. If you put it on the little stick man there, then it enables it to measure the velocity or the position of something that is big and further away. Okay, we're not measuring the position time of you. We're measuring the position and time of this tiny little car that's really close by and moving horizontally on the floor. So it should be already on that setting. But if somebody in the last class messed up on that, you don't want to trust them. Okay, double check that to make sure that that's on the right setting. Now, once you collect data, and again, I'll explain how to do that a little bit later, the specifics of this apparatus, you're going to create a table. And that table is going to be created on a spreadsheet and in a document that you're going to hand in is going to have two columns. The first column is going to be time, and the second column is going to be position. Now, this apparatus is actually going to collect a lot more data than just that. It'll collect time, position, instantaneous velocity, instantaneous acceleration on the x-axis, y-axis, z-axis, the resultant acceleration. It even records actually the sound level via the microphone on your iPhone. Records all kinds of things. The only two columns that we want are time and position. Why do we want those two columns? Because we're going to plot a graph under analysis that's position versus time. Now, that graph is going to have data points that look something like this. They're going to be close to a straight line. So what you're going to do with that is the same thing you've done in Science 10, plot a line of best fit. But you're going to do it in an easier way. You're going to have a spreadsheet do it for you. You're just going to tell the spreadsheet what to do. You're going to tell the spreadsheet, and after you've collected your data, I'll tell you how to tell the spreadsheet to do this. You're going to tell the spreadsheet to plot a line of best fit, and you're going to tell the spreadsheet to determine the slope. Now, what does the slope equal? Well, if you were calculating it by hand, it would be rise over run, right? Spreadsheet's going to do it for you, so you're not going to have to go through that formula. But if you're doing it by hand, you'd use the rise over run formula. Remember what we talked about yesterday with position time graphs? The average velocity is displacement over time. The displacement here, final position minus initial position, is the rise. The time interval is the run. So what we're saying here is this. Yesterday we determined the velocity by displacement over time. What we're saying today is we can still do that, but the slope of the graph is the same thing. The slope of the graph is rise over run. The slope of the graph is displacement over time. The slope of the graph is the average velocity. So you're going to plot this graph. You're going to tell the spreadsheet to plot a line of best fit. You're going to tell the spreadsheet to calculate the slope, and that slope is going to be the velocity of the car. Then you're going to go to your conclusion. Your conclusion has two parts to it. One, what did you find? Well, you found that the velocity of the toy car is whatever. "12 meters per second. That's pretty fast. If you get a speed that's that fast, you're probably wrong. Think about that, 12 meters per second. Okay, that's world-class sprinters, 12 meters per second. Your toy car isn't going to move that fast. But whatever you get is what you write down there. And then your second aspect of the conclusion is, how do you know? So we're going to say this is known because, well, how do you know? Well, we know this in this case because the slope of the graph tells us. This is known because the slope of a position time graph is 12 meters per second, or whatever the case may be. Finally, sources of error. You guys have done this before as well. We want to have 2 or 3 good sources of error. Things that could have been better. Things that could have led to bad data. Not necessarily did lead to bad data, but could have led to bad data. Let me give an example of a bad source of error. I get this all the time, and it drives me crazy. Don't be the person that does that. A bad source of error is, I made a mistake with my calculations. Why is that a bad source of error? Fix it if you made a mistake with your calculations. Right? Fix your mistake. That's not a good source of error. If when you're done the activity, you can still fix it, then fix it. If when you're done the activity, you realize something happened midway through the activity or at the beginning of the activity and it's too late to fix it, that's a source of error. Like for instance, maybe the floor isn't quite level. Okay? So maybe the floor isn't quite level in this activity. The floor in this school is uneven. Okay, you guys have all noticed that the first day you walked into this building, it's crazy uneven. It's terrible. Maybe you were in an uneven spot and therefore it's not a constant velocity. What's the way to fix that? Well, you can't fix it this time, but another time, another group could fix it by checking the level of the floor before you did the experiment. Taking a level, like a construction level, measuring the level of the floor. If it's not level, move somewhere else. Go somewhere else that is level. That's the kind of thing that we're looking for here, okay? So what could have been better? How could it have been better? And we want 2 or 3 good sources of error there. So what are you going to need to hand in for this? Well, we need problem, which I give you already. We need the data. We don't need procedure. We don't need materials, a hypothesis, any of that. We'll deal with that later on. I want to get you good at A, submitting these electronically, and B, the last half of the activity before we start worrying about procedures and hypotheses and materials and so on. You need procedure, you need a problem, you need the data, you need the analysis, which includes the calculation of the slope. I bet your spreadsheet's going to do that for you. Includes conclusion, which has two aspects to it, and it includes sources of error, where you're going to want to have 2 or 3 good sources of error.